Over $1 trillion sits in Bitcoin and other major digital assets right now. Every single Satoshi and fraction of Ether is secured by one mathematical foundation, the elliptic curve digital signature algorithm, or ECDSA. When you send money, you sign the transaction with a private key, and the network verifies that signature against your public key. The physical reality threatening this setup is a quantum computer, specifically, a sufficiently capable machine running Shor's algorithm. To see exactly how this breaks the cryptography, look at this diagram of the calculation. Classical computers would need the age of the universe to reverse engineer a private key from a public one. But Shor's algorithm collapses that impossible exponential formula into a solvable polynomial equation. It derives the private key in a matter of minutes. Because this core mathematical defense collapses, the cryptographic armor protecting most major digital assets is effectively obsolete against mature quantum hardware. The threat isn't waiting for the hardware to finish being built. Cybersecurity adversaries currently operate on a harvest-now-decrypt-later basis. If you have ever sent Bitcoin out of an address, your public key is permanently exposed on the blockchain. Any funds left in that reused address are vulnerable data sitting in plain sight. On Ethereum, the exposure is even broader. Account architectures there natively expose public keys by design, making the entire ecosystem an open target. State-sponsored groups and highly resourced attackers are actively copying and storing this exposed blockchain data today. They are hoarding the locked safes right now, waiting for the quantum key. The window for data compromise is already open, even if the actual decryption happens years down the line. Upgrading these networks means swapping out the cryptographic engine of a decentralized financial system while it trades 24 hours a day globally. Bitcoin handles this by being highly conservative. Implementing a post-quantum signature scheme requires a massive soft fork. That demands almost universal agreement across this immense physical web of miners and node operators. Ethereum takes a different route. Driven by researchers like Vitalik Buterin, the Ethereum community favors an agile roadmap, actively planning protocol changes to migrate to quantum-resistant cryptography much faster. Then there are newer networks like Solana, or blockchains built strictly around post-quantum cryptography from day one. Their modern architectures allow for security upgrades without the heavy structural baggage of legacy chains. Whether your specific holdings survive the migration relies entirely on how effectively your chosen network governs itself and deploys code. The immediate danger is a timeline mismatch. If quantum hardware capable of cracking ECDSA comes online before a decentralized network achieves consensus on an upgrade, the entire chain is exposed. Centralized exchanges holding billions in custody and automated decentralized finance contracts will have to rapidly overhaul their infrastructure. The operational cost and friction of updating thousands of interconnected systems simultaneously is immense. We can see the resulting chaos in this network map. The landscape will fracture into distinct, secure green clusters operating right alongside highly vulnerable red legacy nodes. The riskiest points in this environment are cross-chain bridges. These protocols rely entirely on cryptographic signatures to move value between different blockchains, making them massive targets if one side of the bridge upgrades and the other does not. This multi-year transition period is a high-risk window. Technical implementation errors, lagging protocols, or abandoned smart contracts will lead directly to lost wealth. This timeline tracks the migration window. Roadmap commitments by 2026, production deployments by 2029, and substantial completion by 2032. Practice strict asset hygiene immediately by moving funds into single-use addresses. Taking keys offline into cold storage cannot fix this underlying mathematical vulnerability. You need to procure hardware wallets from manufacturers that provide clear post-quantum firmware updates and actively monitor your specific blockchain's migration schedule. Holding an asset and forgetting about it is no longer a viable strategy. Wealth preservation over the next decade demands active vigilance and precise timing. What happens to cryptocurrency over the next few years is the leading indicator for digital security worldwide. These exact algorithms protecting digital wallets, secure global banking transactions, encrypt private messaging, and the modern internet's architecture. As the cryptocurrency network scales outward, it merges with the broader web of our entire digital infrastructure. They share the exact same vulnerability. The actions taken today to patch these decentralized networks establish the exact blueprint for how the global economy survives the quantum era.